computer. Okay, you have homework 11 due tonight. 2 more left. 2 weeks. That's all we have. Woo-hoo, 2 more weeks. And then quizzes on Monday. I don't know if we're gonna do the scavenger hunt. We'll see how it goes. I mean, we could do it. It's, you know, but thank you. Okay, we're gonna do this example first, and then I'll do homework questions, and then we'll decide whether we want to do the scavenger hunt or not. You can do it at home if we don't do it here, if you want to. Okay, find f of x, given that f prime is 4 secant squared pi x tangent pi x, and f of 2 is 3. So I have the derivative and I want to find the actual function. Yeah, if I have the derivative and I want to find the actual function, what should I do? Take the antiderivative, yeah? Take the antiderivative. What is this piece of information, f of 2 equals 3, going to do for me? Help find the c, right? When I take the antiderivative, I get a family of functions with that plus c in it. If I want to know what c is, they need to give me more information. So I'm going to take the antiderivative of this guy, and then I'm going to use the information at the end to find c. Oh, dear Lord. F of x is the antiderivative of this thing. Okay. What do you think I should do to find the antiderivative of that? I should probably pick a u, right? This is a hard choice for u. Pi x might be okay. If I did pi x, what would be left? Secant squared tangent, right? Do you know how to integrate secant squared tangent?
Cancel it out by comparing the sides and cosines, maybe.
Secant is 1 over cosine, so I'd get like cosine cubed and sine squared? No, sine over cosine cubed?
Wasn't secant squared?
You can't do secant squared.
Go ahead, Braxton.
Isn't secant squared negative tangent?
The derivative of tangent is
Secant squared.
secant squared, right? The derivative of tangent is secant squared. Does that help you?
Yeah.
Yeah, so what are you gonna pick for your u?
Secant.
Tangent, because the derivative of tangent is secant squared. So if you pick u to be tangent, then this secant squared stuff is going to be part of your du. So let's pick u to be tangent of pi x. Okay, what's the derivative of tangent of pi x?
Secant squared.
Secant squared of pi x
And then times pi.
times pi. I need to put that times pi at the end because I need the derivative of the inside, right? I need to put that times pi at the end because I need the derivative of the inside. Okay, let's rewrite this guy. So I'm going to put the 4 in the front because he wasn't used in any of that, right? I'm going to put the secant squared at the end with the dx because he's part of this. Yeah, and I'm going to put the tangent squared at the beginning. So I'm going to rewrite this guy just for a second. I'm going to say 4 integral tangent pi x secant squared pi x dx. Okay, so this guy is u. And this is what I need for du. Do I have it? No, what am I missing? A pi. Okay, if I stick a pi in here, then I need a 1 over pi in the front. Yeah, if I stick a pi in there, I need a 1 over pi in the front. Okay, so now I'm going to put in u's. 4 over pi. The yellow stuff was u. The blue stuff was du. Yeah, okay. How do you integrate u? Add 1 to the power, divide by the new power. So u to the second over 2 plus c. Okay, so f of x is 4 over pi, well, 4 over 2 pi, or 2 over pi. Let me do some canceling. 4 divided by 2 leaves 2. So 2 over pi, u, what was u? Tangent of pi x squared plus c. F of x is 2 over pi. U was tangent of pi x squared plus C. If you want to, you can write this as tangent squared, right? But then when we think about how to compute it, well, I don't know what to do with that. Yeah, let's use this guy. We didn't use this guy yet, so let's use this guy. This guy says that f of 2 is 3. So when I plug 2 in for x, it should spit out 3. So 3 equals 2 over pi times tangent of pi times 2 squared plus c. Okay, tangent of 2 pi. What's the tangent of 2 pi? What's the tangent of 2 pi? Is 0. The tangent of 2 pi is 0. Okay, 0 squared is 0 times 2 over pi is 0. So C is going to be 3. Okay. C is going to be 3 because all of this stuff went to 0. Okay, so in the end, I'm going to squeeze it on the bottom of this page. My function f of x is 2 over pi tangent of pi x squared plus 3. Oh, I did badly. Forgot to put the pages afterwards so that when I put the homeworks in. Okay. Let's see what happens if I do it here. I knew that was going to happen. Control Z. Why did you do that? Okay, I'm going to put it here. Do we have a lot of homework questions or a little homework questions?
I have one.
You got one.
12. Let me check my list.
Let me check my list. Okay. I gotta open the homework. I'm completely ill prepared for class today. Edfinity. Homework. This one's us. We're doing homework 11. Per review. Okay. Which one's yours, Braxton?
11.
11, 12, 10, 3, 13, 7. 7, 10, 11, 12, 2, 3. Someone said 3, 7, 10, 11, 12, 13.
1, 14.
1, 4, 6. Okay. 1. I gotta get that stupid snipper out. Wait, I don't think I left enough pages for that though, people. Okay, let's put some more pages in. Okay. Okay, maybe we'll start by picking U's and DU's, and then we'll go from there. New 1. Control V. 3. Control V. 4. Did you say 4, Shruti? Yes? Not 4. 6. Did anyone say 4? No one said 4. 1, 3, 6. 7. Yeah, we heard 7. 7, 10, 11, 12, 13. I think that's where I'm at. And 14. Fine. No, I refuse. 7. 10. 11. Oh. $13. 14. Oh, 13 and 14 are a lot alike. Once we do one, you're gonna be like, oh yeah, that's dumb. 15. Oh, same with 15. Okay, I'm going to talk about 13, 14, 15 first, because it turns out you don't need u-substitution for 13, 14, 15. Yeah, and that's what's tricky, I think. Because if you look at your sheet from last week, when we very first learned about antiderivatives, this guy is the antiderivative of like arc tangent, right? So this is the antiderivative of arc tangent. So this one will be like 3, because there's a 1 usually in the top. So take that 3 out. 3 arc tangent of x, or 3 tangent inverse of x. Yeah, so it's tricky because you don't need a u-substitution. Look at the antiderivative. Oh, that's not spelled right. Derivative sheet for the arc, sine, cosine, tan functions.
Would it still work if we just like brought the x squared plus 1 to the top?
No, because then you would need a u, because you would do x squared plus 1 to the -1. And you can't, when you take rid of x squared, you need 2x, and you can't stick in an x, right? Yeah. Okay. Yeah, this is gonna work for 14 too, because the, yeah. So this is f of x is -x plus 2 over square root 1 minus x squared. And this guy is like arc sine. Yeah. And then same for 13. This is f prime of x is 4 over square root 1 minus x squared. And this guy again is arc sine. So this would be like f of x is 4 arc sine of x plus c. And then you're going to use this information here they give you to find out what c is. Yeah. Is everybody okay, or do we need to do more of that? You're okay now that you saw those. I know they like hide at the bottom of that sheet, and we threw them in here this week because you're like, oh, I need to use substitution. No, you just need that sheet. Okay, so now I'm going to go back to the top. If we need to do those again at the end, we can. One, using the substitution u equals x plus 6, identify f such that the integral takes the form square root. Hey Jake, remember the one that you guys did on the board on Wednesday or Monday? What day did we do the board from? Wednesday. Remember the one that you guys did on the board on Wednesday, where you had to do like u equals u is x plus 6. So then x is u minus 6. So here, I'm going to use u minus 6. Here, I'm going to use u, and du is just 1, right? So this integral is going to look like u minus 6 square root of u du. I think you can probably leave it like that.
Oh, we don't have to.
You don't have to compute the integral. You just have to say what would the function be in there.
If u was x.
If u was x plus 6, yeah. So that happened in the board problem on, one of the board problems on Wednesday as well. If you solve this guy for x, just subtract 6 from both sides, then x is u minus 6. Because the problem is if I pick this to be u, then this is du, and this x is still here, and I can't have x's and u's mixed together, right? So I need to use that to eliminate that u there.
So I did the
I'm sorry, why is what?
the squiggly line.
You don't need to put the squiggly line in.
Oh,
You just need what is the function inside of there. You don't need the du either. So you just need this guy. U minus 6 square root u.
Do that trick on like other problems that you think have to have accent for, but can't obviously.
Yeah. As long as the thing you're trying to replace is part of your u somewhere, then you could do that trick, yeah. So I'll tell you, like the first 3 or 4 weeks of calculus 2, you basically spend like doing tons and tons of integrals. Like you learn tons of different techniques, all about like using trig substitutions and this thing called integration by parts, and you just learn tons and tons of ways to do integration. The problem is that like 99% of the integrals you encounter in the world, you can't actually integrate, you can only approximate. So then you also learn how to approximate them. But like we teach you tons and tons of integration to do like basically nothing with it. So it's a good method, I think. Okay, 3. What do you want to pick for u here? X cubed plus 9, yeah, pick u to be that stuff inside the denominator there. Okay, so the derivative is 3x squared dx. Okay, let's rewrite this guy. X squared over square root x cubed plus 9 is x cubed plus 9 to the what power? Negative 1/2. 1/2 because it has a square root. Negative because I'm bringing it from the denominator up to the numerator. Times x squared dx. Okay, this guy is u. I want this guy to be du. What am I missing? A 3. So I'm going to put a 3 in there. If I put a 3 in there, I put a 1/3 at the front. Okay, 1/3 u to the negative 1/2 du. I'm gonna stop there. I think you guys can do it from there, right? Yes?
Yeah.
If anyone can, you tell me. How do you integrate? Add 1 to the power, divide by the new power, make sure you plug back in for u at the end, yeah? I don't want to do the whole thing for you. Okay. 6. Oh, same. 6 is same. Let's rewrite it first. X to the 6th minus 3 to what power? Negative 3 times x to the 5th dx. What are you going to pick to be u? X to the 6th minus 3. Pick that stuff inside that's getting raised to a power to be your u. Okay, derivative. 6x to the 5th dx. Okay, so I want this stuff to be du. I'm missing 6, so I put 1/6. Okay, so 1/6 u to the negative 3 du. Whew. Okay, everyone's done writing. 7. Okay. X squared cosecant squared x cubed plus 7 dx. What do you think? X cubed plus 7. Yeah, he's the inside stuff. Okay, if it makes your life easier, put that u stuff at the beginning and put the other stuff at the end, right? Then the dx stuff is together with the stuff you think you're going to use. Okay, what's the derivative of x cubed plus 7? 3x squared dx. So I put my u stuff here. I'm hoping to use this guy as du. What's missing? 3. So put 1/3 in the front. 1/3 cosecant squared of u du. What's the antiderivative of cosecant squared?
Cotangent.
Cotangent u. I think it's positive, yeah?
I don't know.
Is it
I have a
negative?
for my answer that I missed. So.
She says negative.
Sheet says negative, great, negative. Plus c, yeah. You started with x's, so you should end with x's. Cotangent x to the 3rd plus 7 plus c. There you go. I did one all the way to the end for you. Number 7. Whoever chose number 7 was lucky. Did the whole thing for you. Happy Halloween. Okay, no one's writing, so we're good. 10. Oh man, this one looks really hard. All right, if you were a picker, what would you pick?
Thinking cosine x minus x sine x.
You are.
That's what I'm thinking.
What would you do with the denominator if you pick that to be your u?
I'm not too sure.
How do our rules go? Powers, square roots, denominators. Let's try denominator, yeah. 8x cosine x. I actually might, before I start, take these two coefficients, 5 and 8, and put them in the front.
So it's just X. Cosine C.
Whoops. Yeah, because like if I have this 8 in here, it's just gonna like get in the way and I'm gonna have to keep it and carry it around and try not to lose it, right? So like I'm gonna take the coefficients and I can move coefficients into the front as long as I want, as long as they go with every term, right? So the 5 goes with both terms in the numerator because there's parentheses. The 8 goes with the denominator. So I'm gonna take that 5 and 8 and put them in the front. Okay, and I'm picking my u to be x cosine x. What do I do next? Find the derivative. How are you going to find the derivative of that guy? You're going to use the product rule. Man, why did that have to happen? Darn. You're going to use the product rule. The product rule says what? Derivative of the first times the second plus derivative of the second times the first. Okay, so the derivative of the first, derivative of x is 1 times cosine x plus x. Derivative of cosine is negative sine x. Okay, let's simplify that a little bit. 1 times cosine x is cosine x minus, because it's plus a negative, right? Minus x sine x dx. All right, look at this. Let me get my markers out. Yellow. This guy is yellow. He's my u. There he is right down there, right? What happened with that numerator? That's all du, right? Okay, so what does this integral look like when I substitute back in? 5/8 du over u, or 5/8 1 over u du. Yes, sir.
Wait, so how did you know?
Is it
to
natural?
pick- How did you know to pick the x sign in negative sign or the the x cosine for the u?
Because I don't know how to put a du in the denominator. So like if there's a denominator, I have to pick it to be my u. I don't have any other choice. Yeah. Sometimes the denominator will have powers on it and I won't pick the whole thing. I'll just pick the inside stuff. That's why I say powers first, right? So powers rule. But then like if there's a denominator, like if I don't know how to integrate it or how to get it as part of du, I have to pick it. It's kind of like that natural log one, right? I don't know if anybody asked that, but there's that one that has 3 natural logs in it. Same thing. I don't know how to integrate natural log, right? I got to pick it to be my u. I have no choice.
So this is also natural log, right?
The answer is natural log. Because when I integrate 1 over u, I get natural log.
Yeah.
Yeah. So 5/8 natural log of u plus c. 5/8 natural log x cosine x plus c. And I think you have to be careful to make sure put parentheses around your x inside your cosine. I think that's like an infinity thing. But I don't know.
I think it would be the parentheses. And then of the x too.
Oh, instead of the absolute values. I think you can use absolute values or parentheses, yeah.
Like you does have absolute values, so I think that's on it.
Ah, okay. Okay, I don't see any more writing. Let's do it. Find the particular antiderivative that satisfies the following condition. Okay, so the derivative x prime is 8e to the t minus 3, and x of 0 is 7. So to find the function, I'm going to take the antiderivative of this guy. What's the antiderivative of this guy? 8e to the t minus 3. 3t. 3t because my variable is t, right? If I put an x there, then I've got x on both sides and life is sad. Okay, plus c. How am I going to find c? Yeah, when t is 0, x is 7. So when I plug in 0 for t, it should spit out 7. 7 equals 8e to the 0 minus 3 times 0 plus c. Okay, 3 times 0 is 0. That's good. E to the 0 is 1 times 8. 8. Move it to the other side. -1. Okay, c equals -1. No, I didn't need u substitution for this. I know, see? Keeping you on your toes. On the final, how will we know, right?
So we should first check if we can do without u substitution.
Yeah, check and see if you can integrate it. That's always the best plan. Can I do this one? If not, substitution. We maybe could have done that other one where we picked x cosine x and used the product rule. We maybe could have like broken it up and done some sort of integral that way. That's interesting. I wonder if we could have. I think we could have. Cosines would have canceled. We would have had natural log of x. Then we would have had like a tangent or something. That might have been hard though. Okay. You don't. Just the whole thing is just bad. This is 12. Do you know how to integrate arc cosine? You know how to integrate something and get arc cosine as your answer, right? Just like you know how to integrate something and get natural log as your answer. But you don't know how to integrate arc cosine or how to integrate natural log, right? So if they appear in your integral, you got to pick them to be your u and hope everything else that's left there is du. So in this case, we're going to pick u to be arc cosine of 7x. Now you're going to have to go back and remember what the derivative.
It's the same as cosine -1, right?
Absolutely, yeah. Arc cosine is the same as cosine to the -1. You can write it either way, whichever you prefer.
1 minus
We have to go back and remember the derivative of arc cosine.
1 over the square root of 1 minus.
I think it's -1.
Oh, yeah.
-1 over the square root of 1 minus, not just x though, all of this stuff
Oh, so use-
squared, right? So 7x squared times
7 over 7.
times 7, because the derivative of the inside is 7 dx. Okay, let's rewrite this guy. I'm gonna put the 8 in the front because he doesn't matter. I have arc cosine 7x. I have 1 over square root 1 minus 49x squared dx. Okay, so this guy is u. I need all of this stuff to be du. What am I missing? A 7. A -7, right? So I'm missing the 7 and I'm missing the negative. I have a positive there, right? So I'm going to put a -7 in there. If I put a -7 in there, I need a -1/7 or a divide by -7 in the front. Okay, so this is -8 over 7 integral of what's the yellow one? U times du. I'm dying. Not really, I don't think I'm. Okay, -8 over 7 times, how do you integrate u? Add 1 to the power, divide by the new power, plus c. Okay, so -4 over 7, u arc cosine of 7x squared plus c. Okay. All right, nobody asked the natural log question. Yay, I got off easy today. I don't know, which one was it? What was it?
Was that number 4?
Was that number 4? I don't know, let me go look. Yeah.
I might have, I was about to ask.
There's my snipper. No. Uh-oh, if I don't have a spot, oh, I do, you're lucky. Like if I don't have a spot, game over, can't do it. Okay, we do not know how to integrate natural log, right? If natural log exists, I gotta pick it. Okay, that's the only hope I have. So what are you gonna pick for u in letter A? ln x. I'm not gonna pick the 9 because then I'm gonna get u to the 9th. Yeah. What's the derivative of this guy? 1 over x dx. Okay, let's rewrite letter A. ln x to the 9th times 1 over x dx. Agree? Okay, let's rewrite letter B. ln x to the 8th times 1 over x dx. Yeah? What are you going to pick for u in letter B? ln x to the 8th. Yeah. I have to pick the 8 because it's inside the natural log, right? I didn't have to pick the 9 here because the natural log was being raised to the 9th. So I have to put the 8 inside my u. What's the derivative of that guy? 1 over x to the 8th times 8x to the 7th. Okay, let's simplify that because I only have 1 over x left here, right? So 1 over x to the 8th times 8x to the 7th is what? 8. X to the 7th divided by x to the 8th? X to the -1 or 1 over x. So let me get my blue. Well, let me start with yellow. This guy is u. I want this guy to be du. What's missing? 8. So put 1/8 in the front. Yeah. Okay, let's try letter C. I didn't finish, right? I just helped you a little bit. 1 over x ln x to the 8th dx. Okay, I'm going to write this as 1 over ln x to the 8th times 1 over x dx. Agree that those are the same. These two guys are the same. Yes? All I did is pull this 1 over x dx to the end because I think he's going to be my du. Yeah? What are you going to pick for u? ln x to the 8th again. Yeah, let's pick ln x to the 8th. So this guy is u. I want this guy to be du. This is exactly the same one I picked up here, right? So my derivative is going to be what? 8 times 1 over x dx. See up there? Yeah. The other thing is, if you remember your rules about logs, this exponent can come to the front, right? So natural log of x to the 8th is like 8 times natural log of x, which is easy to take the derivative of. 8 times 1 over x. So that exponent can come to the front, and then you don't have to do this simplifying stuff. Okay, I need an 8. So I put a 1/8. So this is 1/8 integral. What's inside here? That will be the antiderivative. What's inside there before I take the antiderivative? 1 over u. Yep. du. Yeah, because the u's in the denominator of this one, but he was in the numerator in part B. So when I integrate this one, I'm going to get natural log. This one is 1/8 u du. When I integrate him, I'm just going to get u squared over 2. Any other homework questions? Okay. Let me stop my recording, stop my sharing, end the meeting.